topic is half wave rectifier. If you are seeing this is the circuit of your half wave rectifier, you are having transformer, you are having diode, and you are having the load resistance. If we are seeing that this is your V input and this is your V secondary. Okay, so at the secondary of the transformer, you are having the voltage Vs. Okay, this secondary voltage is your Vm sin omega t. And if you are going for your Kirchhoff's voltage law, what is the Kirchhoff's voltage law? So in your Kirchhoff's voltage law, if you are having a closed path, then whatever the voltages you are having, that will be summation of that will be equal to your zero. Okay. So here if you are seeing this is your V secondary, this is the voltage across the diode, and this is your voltage say load voltage. This is your load voltage. Okay. Now here if we are seeing, we can say that your Vs is equal to Vd plus Vn. Vn is your load voltage. And here if we are seeing the current that is flowing through it, this is your Id current. So whenever you are having the series path, the current that is flowing will be the same. So only Id current is flowing through it. Now if you are considering this your load voltage we can say it as it is the product of your Id and RL. So here you are having. Okay. So your load voltage we can replace it with Id RL. Okay. Now you from this equation what we can do, we want to know what will be the diode current. So we will keep this diode current at one side and remaining parameter to another side, and there we want to solve it. So there we have got that your Id is equal to Vs by RL minus Vd by RL. This we got. Now let us see the ideal characteristics of your diode. If you are going for the ideal characteristics of your diode, that is your voltage drop across the diode should be 0 and the resistance across the diode will be 0. Now if we are applying your Vd is equal to 0 in that equation, we will get your Id is equal to Vs by RL, because this Vd will be 0. Okay, so what we are having? We are having Id is equal to Vs by RL. And as we are knowing that your Vs is your Vm sin omega t, just we are replacing it, we are getting Vm sin omega t by RL. And what is your what is your this Vm by RL? That will be your Im. So you are having Id is equal to Im sin omega t, where Id is the diode current and Im is the maximum value of current. Okay, and sin omega t. Okay. Next, if you are going for a half wave rectifier, here we are trying to see that what will be your average current and what will be your RMS value of current. So suppose if you are going for your average value of current in case of your half wave rectifier, it will be your Im by 2 pi integrating 0 to pi sin omega t. If you are solving this, you will get the answer. Okay. Similarly, if you are going for your RMS value, RMS stands for root mean square. So if you are going for your RMS value of current, it will be your square root of Im square by 2 pi integrating 0 to pi sin square omega t d omega t. So if you are solving this integration, you will get the value of your RMS current. So this average current and this RMS current,